So what exactly is 0 raised to the power of 0? In this video tutorial, I would like to show you what 0 raised to the power of 0 is in essence. So first thing first, let's think about 0 raised to the power of other index. So what exactly is 0 raised to the power of 1? Notice that will be 0, 0 raised to the power of 2, that will be 0, 0 raised to the power of 3, that will be 0. In fact, as the index is positive, the result will always be 0. But what if we consider negative index? 0 raised to the power of minus 1. Will this be 0? Notice that will be 1 divided by 0 raised to the power of 1, which becomes 1 divided by 0, which becomes undefined. Similarly, 0 raised to the power of negative 2 becomes 1 divided by 0 raised to the power of 2, which eventually results in 1 divided by 0, which is also undefined. So there's no point in time that we can clearly say that 0 raised to the power of 0 is 0, since 0 raised to the power of n won't be true for all value of n equals real numbers or complex numbers. Notice that as the index changes to several kinds of numbers, then the result will continue to be much more complicated. 0 raised to the power of fraction or negative fraction, we can't really determine what the result will be. Talk less of saying 0 raised to the power of I or complex numbers. So this is totally out of it. Now let's consider the quotient law of indices. 0 raised to the power of 1 divided by 0 raised to the power of 1. What would this be? Notice that from the quotient law of indices, this can become 0 raised to the power of 1 divided by 0 raised to the power of 1. And eventually, this becomes 0 raised to the power of 1 minus 1. Then we have 0 raised to the power of 0. But what would have been the result? In fact, this is totally out of it as well, because in all textbooks, the law is stated in such a way that it is specified that the denominator must not be 0. This is how the law is stated. It's stated that when you have a raised to the power of x divided by a raised to the power of y, this is the same as a raised to the power of x divided by a raised to the power of y. And you can simplify this to a raised to the power of x minus y. However, a must not be equal to 0. So why would we make use of it here when a is 0? So this is totally out of it as well. So let's consider the third case and see what would happen. So what is 1 raised to the power of 0? That is 1. 2 raised to the power of 0? That is 1. 3 raised to the power of 0? That is 1. In fact, as the base continues to increase positively, the result will always be 1. Not only that, for all numbers, for all variables, anything raised to the power of 0 always results in 1. Regardless, either it is complex, square root number, fractions, or real numbers, the result will always be 1. Since 0 is among real numbers, then definitely we can clearly say that 0 raised to the power of 0 is indeed equals to 1, because 0 and 1 raised to the power of negative 0 becomes 1 divided by 1 raised to the power of 0, which end up with 1 divided by 1, which is indeed equals to 1. Similarly, 2 raised to the power of negative 0 becomes 1 divided by 2 raised to the power of 0, which becomes 1 divided by 1, because 2 raised to the power of 0 is 1. And eventually, we still have 1. So regardless of what the value is, once it is raised to the power of 0, the result will be equals to 1. So we have no reason for not saying 0 raised to the power of 0 is not equals to 1. Many mathematicians agree that 0 raised to the power of 0 is equals to 1. Now, you might be like, you have no reason for knowing what 0 raised to the power of 0 is, as you might have never made use of it in mathematics before. Well, if you take calculus, then you might have encountered a situation whereby you make use of it, but without you realizing it. An example of that is the binomial theorem. So what says the binomial theorem? The binomial theorem said that when you have a plus b, either they are variable or numbers raised to the power of n, the result will be the summation from k equals 0 all the way to n, then n combination k, a raised to the power of k, b raised to the power of n minus k. Now, what if we consider a to be 0 and n to be equals to 2. And notice that we can now have 0 plus b raised to the power of 2 to now be equals to the summation from k equals 0 all the way to 2 combination k, a raised to the power of k, b raised to the power of 2 minus k. Now, from your algebra, you notice that the left-hand side will be nothing but b raised to the power of 2, as 0 plus b is b. And if you raise it to the power of 2, you have b squared. So let's see if the right-hand side will be nothing but b raised to the power of 2 as well. Notice that if we simplify this, we now have, when k is 0, we have 2 combinations 0. A is 0, 0 raised to the power of 0, b raised to the power of 2 minus 0, which is 2. Plus, the summation means adding them up. When k is 1, 2 combination 1, a is 0, 0 raised to the power of 1, b raised to the power of 2 minus 1, that's 1. When k is 2, we have 2 combination 2. A is 0, 0 raised to the power of 2, then b raised to the power of 2 minus 2. Simplifying this forward, we now have b squared to be equals 2 combination 0, that is nothing but 1, multiplied by 0 raised to the power of 0, multiplied by b squared, plus 2 combination 1 is indeed equals to 2, multiplied by 0 raised to the power of 1 is 0, then we have b, because b raised to the power of 1 is b, plus 2 combination 2, that is 1, multiplied by 0 squared is 0, then 2 minus 2, we have b raised to the power of 0. Notice that we will be left over with b squared equals 1 multiplied by 0 raised to the power of 0 multiplied by b squared. Now this whole term will be nothing but 0, because we have 0 to be multiplying there. So now, if 0 raised to the power of 0 is not equals to 1, then definitely this wouldn't have been true. But if 0 raised to the power of 0 is equals to 1, then this will always be true. B squared will always be equals to b squared. So now, does that mean if 0 raised to the power of 0 is not equals to 1, then the binomial theorem is not true? Let me know, do you agree with this or not? Let me know in the comment section below. Hopefully you now know what 0 raised to the power of 0 is. Thanks for watching. See you guys in the next video. Bye for now.